We're now going to talk about what you should have kind of figured out in the investigation from the end of B is what happens when the function itself is below the x-axis. So basically, if the function is negative below the x-axis, then the area is the opposite of the integral. It's the opposite of the integral because the integral under the x-axis represents a negative value, where the integral above is a positive. So if we want to find the area, we're just taking the opposite of the integral. And this will make a little bit more sense. All right, so let's talk a little bit about proofs. Sometimes you have to show things on IB, and it does not need to be tricky. So why is this the opposite? So let's think about if we've got this function f of x below the x-axis, if we reflect it above the x-axis, it's just the opposite of the function. So area is going to be the integral, once we moved it above, of the opposite of f of x. And this is like a constant, -1, that can be pulled out in front of the integral. This is literally the proof. You just need to state by symmetry. We know that if we reflect f of x above the x-axis, we now have negative f of x. So then and then this is all above the x-axis, so I can just integrate this. Okay, so this says find the area bounded by the x-axis and y equals x squared minus 2x. So think about on your non-calculator portion. If this is a calculator portion, I would absolutely just graph it on your calculator and you can see everything. So if you don't, we first need to figure out where's the graph. Now what I would do, because you don't usually remember how to graph your parabolas, I would just find where does this cross the x-axis. So I would set the equation equal to 0 and factor. There's a GCF of x. This tells me that this graph crosses the x-axis at 0 and at 2. So let's just figure out where's the graph at 1. If I plug 1 into the equation, I get 1 minus 2, which is -1. So here is my parabola. All right, so see how the area is below the x-axis. If we want to find the area, we just do the opposite of the integral from 0 to 2 of x squared minus 2x. The integral value itself will be negative, so this is just making it the opposite of a negative, which will make it positive. So anytime it's below the x-axis, you just change the sign and make it positive. All right, so I'm going to put big parentheses here. Just bring that negative down. So we just add 1 and divide. Add 1 and divide. The 2's cancel from 0 to 2. Don't forget to bring that down. You'll know later though. All right, plug in 2. That's 8/3 minus 4. And then this whole thing will just be minus 0 when I plug 0 in. So 4 over 1. If I need to subtract, I need to get a common denominator. So I'm going to multiply by 3. 12/3 is the same as 4 over 1. 8 minus 12, this is -4/3. So what this is saying, the integral value is -4/3, but because we're looking for area, that's why we need this. This is saying it's going to be the opposite of whatever this is. which is positive 4/3. So the area is 4/3. Because it's below the x-axis, that's why the integral value is negative. All right, so find the total area of the regions contained between the curve and the x-axis. All right, so here's a whole bunch of stuff. Notice how they all have an x. I'm going to factor out the x. Then this quadratic can be factored. So factor the inside. X and x, factors of 3 that subtract to get 2, plus 3, minus 1. All right, so our zeros, our x-intercepts are 0, negative 3, and positive 1. So let's consider the graph. Negative 3, 0, positive 1. Now let's think about, what do x to the third graphs look like? They start from negative infinity, goes up, down, up. This is the basic shape of x to the third. So if we have all three zeros, we can just connect the dots. So we want the total area contained by the x-axis and the curve. Now, this area, this integral value will be positive. So let me call this area 1, because anything above the x-axis will have to be separated from anything below. Because area 1 is all above, I just need to take the integral value from negative 3 to 0 of my function. Area 2, the integral value is negative, so I need to do the opposite of the integral. All right. So here's where I need to take this function and do the integral, the antiderivative. So I'm going to add 1 and divide, add 1 and divide, add 1 and divide from, negative 3 to 0. So this is a pretty miserable function to integrate, a whole bunch of fractions. Luckily, I'm going to have 0 a couple of times, so that's going to help. So if I plug 0 in, 0 plus 0 plus minus 0, that whole first part is just 0. Minus, here's the trickier part. Negative 3 raised to the 4th is 81/4. This is going to be a minus because if I take negative 3 to the 3rd, that's negative 27, so that makes that a minus. So this will be 2 times 27 divided by 3. Let me write it this way because that'll get rid of our fraction. Minus negative 3 squared is 9 times negative 3 is minus 27 halves. Okay, so I would probably cancel this out and get 9. So that's going to be 18. Let's change this into fourths. So this will be minus 54/4 if I multiply top and bottom by 2. Then, all right, so let's 81 minus 54, that's 7, 27/4 minus, all right, let's take this times 4. So that's 72/4. So we can see this is negative. So this will be the opposite of a negative. So I'm just going to say this will be positive. When we subtract these two, we get 45/4. So that's this area here. 45/4. All right, area 2 should be a lot easier because I'm going from the opposite, because it's below, I have to do the opposite, from 0 to 1. Because f of x is defined up there, I don't need to keep writing it. All right, so I'm going to use my same antiderivative, x to the 4th over 4, plus 2/3 minus 3/2. Let me make a little more room from 0 to 1. Okay. So when I plug 1 in, I get 1/4 plus 2/3 minus 3/2. This is the whole top part, minus when I plug 0 in for everything, I get 0. So this should be negative. All right, so if we make this will be 12ths. So this will be 3/12. This is times 4, 8/12. And this will be 6, 18/12. So 3 plus 8 is 11, minus 18, negative 7/12. Because this is a negative area, negative integral, that's why I need this negative here to make it positive. All area has to be positive. So what this is saying is I'm going to do the opposite of the integral value of negative 7/12, which is positive 7/12. So if I take 45/4, and typically what I do, I write total area. So I'm going to take my 45/4 plus my second area, 7/12, and altogether I get 11 and 5/6. So whenever you're finding area, all of this should be positive. That's why over here, if you would have forgotten the negative, you would have gotten here and gone, oh, wait a minute, I need to do the opposite of this because I can't have a negative area.